Welcome to the High Voltage Light Electric Vehicle channel. Sorry it's been a while without any kind of update video, but it's been a pretty crazy time of the year trying to get everything at the house ready for winter, as well as everybody out there panicking over the insulation that they should have sorted out like months ago. So the plan this week was to talk about the Elite light frame that we've been working on with various people on Discord as well. But it's been a bit delayed, mostly because of time reasons. It should be next week now. Some aspects of it are blurring into the plans that I have to design my own frame system, so we can talk about those then as well. For this video though, I thought it would be fun to give a quick tour around the little space where I do most of my work, or I guess my kind of Batcave, I suppose. You'll notice that probably most of the things that I make for high voltage and elsewhere involves 3D printing. So the bulk of this space is dedicated to exactly that. If you're not interested in the fabrication side of things, this is probably not the video really for you. But if you are, I'll show you the machines that I use. I actually, quite exciting, I have my very first CNC machine arriving in a week or so. So that's going to allow me to expand into some aluminum part production, some prototyping, as well as routing of polycarbonate and other solid chunks of material. The machine is not actually going to be located in this room here because the inevitable dust and debris is not going to get on too well with the 3D printers. So that's actually going to go next door in the sort of garage kind of area, but that's an overwinter project to get that space sorted out because it's a bit of a mess right now. So this room, as you can see it right now, is something that's gradually taken shape over the last sort of 2 years. And it's still not 100% of where I want it, but it's starting to get there. And I just need now to sort out some nice LED lighting, things like that, get things properly tidied away still. So over here, is where I do most of my computer work at the moment. So this is where I sit when I do either sort of video production or any kind of CAD work. And right now I'm on the laptop, but I would like to get set up at some point with a desktop rig with a bit more processing power. But this is fine for the moment. And on the screen you can actually see some progress that I've got on my design for a modular rear hub, and there'll be more on that with the Elite video. So the machine that you can see here on the right is, the machine you can see here on the left is actually the very first 3D printer that I bought, which is an Ender 3, although it's been extensively modified since its original configuration. It's been enlarged from sort of 200 millimeters to 400 millimeters. This is actually the very first 3D printed part that I ever made for a bike, and this mounted the back 800 onto my fat bike. And this is the latest version of the mount that we send out with the high voltage kit. There's a quite a difference in a couple of years. The Ender 3 is a pretty good machine for learning on if you're new to 3D printing, to build something and learn about how all the different parts and components to work. And if you've ordered from me though, or if you've ordered parts from me or had parts from high voltage, most of those will have been made on the presser machines. And we've got 2 of these over here, and they deliver a very good print quality with minimum startup time, and they're really reliable. They're not like the fastest in the world, but it certainly takes a lot of the stress out of manufacturing if you know that 99% of the time it's going to come out without any fuss at all. So these 2 here are the larger Mark III models, and they have a direct drive extruder. So essentially with a direct drive extruder, the filament goes into the top here, and there's a motor, and that forces it through, and it comes through and injects out of a nozzle here, and then it's built up in layers on the bed here. And these are also known as bed slingers because the bed is what moves backwards and forwards on the y-axis, and the x-axis moves backwards and forwards up there, and then the Z is on the 2 linear bearings here that go up the side. having this really short filament path allows you to use the flexible filaments like TPU quite easily with this. So next to this one is actually the latest version of the Ender printers. This is the Ender S1, and right now I'm using it to print some of the low profile plugs. This has some nice quality of life improvements. It has like your filament run out sensor, it's direct drive, and it has automatic bed leveling, which none of which the original Ender did. Right now I'm mainly using this one to print the Molex plugs that I do, and these ones are a new sort of ultra low profile version, which if you look at them here on the back 2000, you can see how close that's going to let you fit this to a flat surface. Normally the wiring ejects straight out the top in quite an annoying way, so this lets you get your back really close to a bike frame. Above that we have this nice map of the world, and one day I'm going to start putting in pins to indicate where I've sent stuff to in the world, because I thought that would be kind of neat. If we come across here, we can see we've got a whole bunch of different filaments that I use. So we've got some PLA, PTG, TPU, carbon fiber, polycarbonate. There's a bit of standard polycarbonate as well in there, and then a whole bunch of like weird, wacky stuff like glow in the dark and rainbow and stuff for making things, mostly for the kids when they want it. If we come over here and we have a look at the shelves, these are more Prusa machines. These are Prusa minis, and these are kind of the real workhorses. They do a lot of work, and they produce a lot of smaller parts, mounts, BBS HD covers, things like that, and they're really reliable. They're a slightly different version. They're still bed slinger printers. They move the bed backwards and forwards on the y-axis. They have a single gantry point at the back. They're what they call a Bowden tube. So to keep the print head nice and light, it has the extruder motor at the back here, and that forces the filament through down into this part here. The only sort of drawback with that is that it's very difficult to print sort of TPU and flex materials very reliably, or with any kind of degree of speed with those. Coming down here, we have another Prusa Mark III machine, and this one is going to be partially dismantled and incorporated into an enclosure, and that's going to let me print a bit more reliably in some of the higher temp materials, some of the tricky stuff like nylon, ABS, polycarbonate, things that tend to want to warp off the bed if you're printing with any kind of unusual shapes. And coming around the corner of the back here, we have my sort of little electronics station here, which is not a huge amount. The electronic stuff is not really my forte, but I do like to learn about it, and I do like to do bits and bobs. So what we've got here is a Tramper 250 amp continuous VESC unit, and I'm building a harness that will let me hook it up to the BBS HD. I figure start off with something new, and at the minimum it'll be some fun, and it should also give me some appreciation of the kind of jobs that Greg and Mike do like so bloody easily. But yeah, so that's just a basic harness at the moment with some PAS wiring and hall sensors and a power switch, and I've got to figure out sticking the throttle in as well. This sort of octopus thing is what I use to hold various things to solder with. So the last thing is to come around and take a look at this big giant printer in the middle. This is a 500 by 500 millimeter printer, and this is by a company called Ratrig. So this printer has some very interesting features that come with it. So it has this huge bed, which is a single piece of cast aluminum that's been machined flat. So there is a 0.2 millimeter height difference at any point in this. So there are some little bits that like fractionally higher and lower than others, but overall, like it varies by less than 0.2 of a millimeter across the top. And it's kept that way because it's mounted at 3 points with these ball bearings here, or not really ball bearings, they're sort of screw-on ball surfaces, and they sit, if you can see there, on 2 rails with a magnet underneath. So there's one there, and there's one on this side, and there's one underneath at the back there, and they're all on 3 screws. So that gives you 3 points of contact, which holds it up, so it can't tip, it can't fall, and it uses those 3 points to level the whole bed. And when it heats up, it expands evenly across, so you don't get any sort of thermal expansion causing warping, which you do get on this one, because this one is secured at 4 points, and they are fixed points and they don't move at all, unlike this one where if it does expand, there is room just to let it slide along these rails. So it will literally probe 3 points, 1, 2, 3, and then it will remember a mesh or a height mesh for the rest, and you'll get a perfect first layer print every single time. And this is what they call a Core XY printer, and it lets you print significantly faster than either these machines or the other presser machine there. So this machine will print like at least 3 times quicker, and it does that because it's dropping the bed down with the screws rather than moving the bed backwards and forwards. So all that weight and slop, you can't wang it around too fast, otherwise it would just result in really terrible printing. So the Z is on, lifts the bed up and down, and then the X is across the gantry, and then the Y moves the gantry backwards and forwards, and that's all done just on 2 motors at the back. The real sort of wizardry with this is in its ability to print fast, and it does that with something called input shaping. And normally you can't print very fast on a 3D printer without losing massive amounts of quality. And the reason you lose quality is because as the printer moves faster and it accelerates faster, it shakes and resonates the printer. And you can see with this, you can actually see the patterns as it gets faster. So it's starting at slow acceleration at the bottom and fast acceleration at the top. And as it accelerates faster and faster, you can see more and more resonance or ringing. You can see it in the back. It's dramatic on the back, the ringing effect that it's caused. So basically, as the print head accelerates away, it shakes, and that pattern is in all of the print surfaces. So what you do to get rid of that is you mount an accelerometer on the print head here, and you just park it in the middle of the bed, and it shakes the print head in both the Y and the X axis through 200 hertz, I think it is, of frequency. And then it just does some algorithm on the clipper print host. And then once that algorithm is in place, this is the same test. So it eliminates all of the artifacts from that. There's still a little bit of artifacting, but that's not from that. That's from something else that I can tune out. I can get rid of these sort of vertical lines as well by doing something else, which I haven't done yet. But it's a pretty dramatic difference. You can see it even more with this BBSHD cover here. So the one with the horrible ridges all down it, all the way around that as well. That was printed in 50 minutes. And then the one next to it, this one was actually printed in 34 minutes, and it's much better quality. And then this one was printed in, I think this one took an hour, and it's another step up in quality again. So I'm not going to print like insanely fast, but it's nice to be able to print a little bit faster for prototyping or for making larger projects. So that is the RatRig V-Core 3.1 500 by 500. So that will be integrated into my workflow pretty soon once I've done a bit more testing on it. So that's it for the video today here, and hopefully I didn't send everybody to sleep with all the stuff about 3D printing. Look, I sent Dando to sleep. She's She's absolutely tated. But yeah, hopefully I didn't send you all to sleep by talking about 3D printing and things. If you're interested, I can definitely do some more stuff on the fabrication side of things. Maybe go into a bit more detail if people would like me to. If it's totally boring, then don't worry about it. I'm going to do my very best to get the e-leak stuff finished up, ready for a video on that next week. And there's definitely a lot to talk about with this frame now, as well as my own plans for a frame as well. So hopefully I can get that all together, or most of that together, for next week's video. Anyway, thank you very much for watching the channel, and a massive shout out and thank you to everyone who has joined the channel and are contributing directly to the upkeep of the channel. It's very much appreciated. See you in the next video. Cheers.